Time to go behind the pump panel and understand how the waterless priming system operates. Priming operations usually begin when the onboard water supply of the apparatus is near or has been depleted and there is no municipal or pressurized water source immediately available. To better understand the priming process, let's briefly describe what events need to take place before the centrifugal fire pump can flow water. Priming is the process of replacing air in the intake hose and portions of the fire pump with water, which requires the use of a positive displacement pump. When operating from the apparatus booster tank, priming will be accomplished more quickly and positively when the waterless priming system is utilized. When operating from a draft using an auxiliary water supply, the waterless priming system is a must to quickly prime the centrifugal fire pump. The waterless VPO priming system utilizes a positive displacement eccentric rotary vane pump. The waterless priming system is NFPA compliant and meets or exceeds the standards of NFPA 1901 standards for automotive fire apparatus. The waterless priming system is environmentally safe and utilizes green technology, eliminating the need for priming oil to operate the system. The waterless priming system consists of three main operating components, and they are the priming switch, located at the pump operator's panel. The priming switch utilizes a weatherproof switch and wiring connections, and when the button of the priming switch is pressed, the electrical circuit is completed and current flows through the switch and into the solenoid on the priming motor. Once the solenoid on the priming motor receives power, it closes and allows battery voltage to engage the priming motor, which results in its internal shaft rotating at approximately 2300 RPM. The waterless VPO model priming pump is direct coupled to the priming motor and consists of a head, cylinder, eccentric rotor, and four composite vanes that slide in and out as the priming pump is operated. When the composite vanes make contact with the inner wall of the cylinder, they create a seal, resulting in a vacuum being created within the priming pump and the rigid hose connecting it to the vacuum-actuated priming VAP valve located on the top side of the centrifugal fire pump. The VAP valve is located at the highest point on the intake passage of the centrifugal fire pump. The VAP valve consists of the valve body, return spring, and a diaphragm seat assembly. When the vacuum increases within the VAP, the diaphragm is lifted from its seat and completes the circuit between the priming pump and the intake of the centrifugal fire pump. As air is forced out of the exhaust of the priming pump, the vacuum increases within the intake side of the centrifugal fire pump. Once the pressure within the centrifugal fire pump is less than the atmospheric pressure, water is pushed up the suction hose and floods the centrifugal fire pump. At this point, the pump has been primed.